Good afternoon to all. I am Dr. P. Vichayamanikam from Department of Computational Intelligence, SRM Institute of Science and Technology. Today's session, we are going to discuss about the circular queues. So in the last class, we have discussed about queues and dequeues. So what are all the operations of the queues? Everything, how to represent the queues in terms of array as well as the linked list representation. So here the circular queues. So what is the use of this? What are the operations of circular queues? And so how we are going to implement in C program. So these are all the things we are going to discuss. And first one thing is circular queue. So the circular queue means what is it? This is a variation of and the traditional linear queue. So normally what we are going to do that there is here with the help of this circular queues, the waste spaces can be utilized properly for doing some more operations only with the help of this the front and rear operator. For example, what I am telling is that suppose the last element that should connects back to the first element. So normally that is another one more the important thing. So the last element of the element that should be connected to the first element, so forming the circular structure. So this ensures that the continuous use of memory as well as the efficient space utilization. Here, another one more thing is here we are using the two different pointers, that is called as the front and rear pointers wrap around the array that are allowing us to enqueue the elements at the rear and dequeue elements at the front. For example, normally what we are dealing is the front operation, and with the help of this the front pointer, we are going to deleting the elements from the stack, and my enqueue means we are going to insert an element into the stack with the help of this the rear pointer. Okay, so what is the need of this the circular queue? So here it is a very standard linear queue implementation using arrays. That is the limitations in reusing the vacant space. So this is one of the major utilization. Normally we are using that there is some spaces are there, some 5 to 6 spaces are allocated on the stack or queue, and we are inserting some more element into the queue or deleting element. There is remaining space are not properly utilized. So here the main objective is we are going to reusing the vacant space left after dequeuing the element. So this is one important aspect. So another one more thing is here with the help of this circular queue, we are using this unused memory space at the beginning. So it is inefficient memory that can be overcome by the help of this the circular queue. So we are going to consider this the circular queue. So need for circular queue. So another one more thing is what are all the circular queue operations? So here we are going to discuss so many operations: NQ operation, DQ operation, front operation, rear operation, is empty and is full. So NQ operation means so we are going to adding the element in the rear of the queue. DQ means we just removing the element from the front of the queue. Already know there is a front and rear. So NQ means this is an insertion operation. Insertion operation only done at the end of the queue, rear of the queue. So DQ means we just remove the element from the front of the queue, and front means we just accessing the front element of the queue without removing it, and rear means access the rear element of the queue without removing it. So another two more important point is that there is empty and is full. Empty means that is whether we are going to check whether the queue is empty or full. So empty means we are not going to delete any element. So is full means we are not able to insert any element. So these are all the two important important function for checking the behavior of a circular queue. And next one is circular queue implementation. So we just take some more reference point. There is max size queue, front and rear. So maximum size there is it should represent the maximum size of the circular queue, and queue. So what about the queue? There is this is an array that holds the element of the circular queue, and there is a two different pointers are utilized. One is the front pointer that should represent the front of the circular queue, rear, and the pointer to the rear of the circular queue also. So constructor to initialize the circular queue. So what is the constructor we are going to use? That is here we are using there is circular queue we are using this the max size, maximum size we are using. There is maximum size is equal to max size. Q is equal to none of n into maximum size, and the front is equal to rear minus one. So these are all the constructors are utilized to realize, or we are going to define the circular queue. So what is the function going to check the is empty? So is empty means return front is equal to minus one. So if the circular queue is empty, means it returns as minus one. The function is to check the circular queue is full. That is return rear plus one modulus of max size is equal to front. Already know that is rear plus one modulo rear plus one modulo maximum size is equal to 20. Both are equal. That is the circular view is full. Another one more thing is important thing is that the insertion process, or what about the insertion process, the NQ process. So here we just check the is full, and suppose if the function returns true means the Q is full. Suppose if is underscore empty means that is front and rear is equal to 0. So the circular view is empty. Okay, so is if else. So what about the else? Else means there is the increment the rear pointer in the circular manner. There is rear is equal to rear plus one modulus modulo maximum size. So maximum size. So here Q of rear is equal to data. Q of rear is equal to data. So returned NQ'd element. So what is meant by the NQ means, so we are going to insert an element into the we are going to insert into the element. So here NQ of data means is if is full. So is full means definitely it should return the Q is full. So if is underscore empty means that is front is equal to rear is equal to 0. So else means rear is equal to rear plus one modulo maximum size. So the corresponding data that should be assigned with Q of rear is equal to data. So return the NQ'd element. So DQ element. So what about the DQ element? So DQ element means that should represent a deletion operation. Deletion operation. So we just check it is empty. If the condition is true, so automatically it should return Q is empty only. So data underscore Q is equal to Q underscore front. So we just check the if front value is equal to rear value, that is front is equal to rear is equal to minus one. So else means front is equal to front plus one modulo maximum size. So we are having the maximum front is equal to front plus one modulo maximum size. So return the data to the DQ. So this is the DQ process. Okay, NQ and DQ process is over. Another one more thing is the front element of the circular queue. Circular queue. So what about the front element of the circular queue? That is peak element. So if is empty means we just check it, check the behavior of the front. If it is empty means return Q is empty. So return Q of front. And next one more thing is the rear element of the circular queue. So how we are going to check the rear element of the circular queue? So peak underscore rear. So if is empty means return Q is empty. So return Q of rear. Another one more thing is what are all these are all the operations for implementing the circular queue. Another one more thing is advantages of the circular queue. So what are the advantages? So efficient memory utilization. And here there is no wastage. So what is the meaning? There is the waste space can be reutilized properly for by reusing the vacant slot. And next one is the simplicity in implementation. So this can be implemented by using arrays also. Another one more thing is continuous data flow. So circular queues are allows the continuous data flow without the need of resetting the front point. Okay, so these are all the advantages of the circular queue. Another one more thing is applications. So what are all the applications where we are using this in the circular queue? So first one is the printer pooling. There is the printer pooling is the meaning is that is we are going to manage the printer job in the printer queue. Another one more thing is the CPU task scheduling. So the task scheduling is an important process in the operating system. Another one more thing is the buffer management. So handling the data packets in the network router. So these are all the applications of the circular queues. Okay, thank you.